What is up, teams? Today we're talking about equations of parabolas. What's a parabola? A parabola is that smiley or frowny face-shaped thing that you get when you graph a quadratic. So there's a few different types. We have ones that point up, point down, point to the right, or open up to the right, and open up to the left. We'll talk about more of that in a minute here, but they can go all the sorts of different directions. Here's an example of one, and the technical definition of a parabola is it's the set of all the points that are each equidistant from the focus and from the directrix at the same time. Yikes, what does that even mean? That means if we pick any point on this parabola, how about I pick this point right there? I don't know the coordinates of that point. I super don't care. It's true for all of them. This point is exactly the same distance away from this blue point that we called the focus. So this distance right here is the exact same as the distance between that same point and what we call the directrix. Pretend that's a straight line. So these two red lines, I'll just call them, give it a value of A. Don't know what it is exactly, but I know that they're the same. And that's true for every single point on every single parabola ever. There's always a focus and a directrix. Now, we don't always talk about them. A lot of times we just graph x squared and, say, boom, cool, nice. But what's going on behind the scenes is this focus and directrix stuff. Just to illustrate the point a little bit further, say we picked this point right here at the origin, which happens to be the vertex of this parabola. The distance from it and the directrix is exactly 2 units. Same is true of the distance between the focus and the vertex of the parabola there. Okay, so the objective of what we're trying to accomplish today is if you're given a focus and you're given the directrix of some parabola, can you create the equation of that parabola? That's what we're trying to accomplish today. So we're going to look at a few different examples and we're going to make it happen. So first, let's work on the one that we've been looking at here. So it points upwards, or it opens up upwards like a smiley face. Cool. We have this directrix at y equals -2. We have a focus up here at 0, 2. So there's 4 general equations for these parabolas, depending on which way the parabola opens. Opens up, down, or to the left, or to the right. So here, ours is opening up. So we're going to focus on this first one, and we're going to ignore the other 3. So it's y equals x squared over 4p. X and y stay the same. X and y are just going to stay x and y. So our task is to find what the p value is in this case. Now the p value, that represents the number. In this case, it happens to be 2, spoiler alert. It's the distance between the directrix and the vertex, and it's also the distance between the vertex and the focus. So those have to be the same exact number necessarily, like by definition. In this case, it happens to be 2. So we would say that our p value is 2 for this one. And we're going to use that top equation, number 1. So I'll just rewrite it. Y equals x squared over 4p, and then we'll substitute this value in. So y equals x squared over 4 times 2, which is 8. So there we go. This is the equation of the parabola that we're working with here. Y equals x squared over 8. So really when you're creating equations for these, when you're given the focus and directrix, you need to figure out what the p-value is, and you need to figure out which way your equation is pointing so you know which one to use. There are some indicators that will help you figure it out. Of course, if you have the picture, you can tell really easily which way it's opening up. If you're given some words like this one, you got to do a little bit of critical thinking. So let's walk through it. This parabola has a focus at -3, 0, and a directrix at x equals 3. Okay, so huge clue here. X equals 3 is the directrix. That's an up and down. When it's x equals something, that's a vertical line. Over here, we had a horizontal directrix, y equals stuff. So if it's an up and down directrix, that means this thing is either going to open to the left or to the right. We got to figure out which, but this is good news. We've eliminated 2 of the possibilities. It's going to be one of these 2. So I'm pretty visual. If I see something like this, I'm probably going to sketch it out real quick. And by real quick, I mean real quick. So here's xy axis. If my focus is at -3, 0, means it's over here somewhere. If my directrix is at x equals 3, that means it's over here somewhere. Well, what I know about parabolas, and what you are about to know, and you should take into account every time you're working with these, the focus needs to be inside the parabola. Focus is always inside the parabola. directrix is always the opposite direction of which it's opening up. So here, the directrix is horizontal, and the parabola opens up away from it. The same is going to be true over here. So the focus is going to be inside, the directrix is going to be behind it. So the one that we're working with right now opens up to our left. Okay, so that's this one here, equation number 3. So we still need to figure out what our p-value is. The p-value, remember, is the distance between the directrix and the vertex, but also the vertex and the focus. They're the same value. In this case, it looks like that's going to be 3, the picture I drew, we can't really base things off of that because that picture doesn't account for where the vertex actually is. So what we're going to do is we're going to look at really just the difference in these two values. So ignore the parabola, but do acknowledge the directrix and the focus. The directrix is 3 units away from the origin, and the focus is 3 more units away from the origin. So generally when I'm looking at something like this, I recognize like, hey, 3 is 6 units away from -3. Great, chop that in half. Half of 6 is 3. So our p-value is 3. Again, that's the distance between the vertex of the parabola and the focus. It's also the distance between the vertex of the parabola and the directrix. Okay, p is 3. We're using equation 3. X equals y squared over 4p. Plug our value in. X equals y squared over 12. There we go. That's it. Some folks like to solve these things for y. You're welcome to. If you multiply both sides by 12, we get 12x equals y squared. It's pretty common to leave it here, or maybe y squared equals 12x. They both work. It wouldn't be super common to see a y equals the square root of 12x. That'd be annoying. It'd be true, but it'd be annoying. Okay, 2 steps to these. First, figure out which way your parabola is opening, up, down, left, or right. Then choose the appropriate equation. Your next step, find the p-value. It's the distance between the directrix and the origin. In this case, it's going to be the origin, or the distance between the focus and the origin, which is going to be the vertex of all of these parabolas. Another way you can look at it, if you just have words, is really it's half the distance between the directrix and the focus, because the vertex must be immediately in the middle. These two are 6 units away, half of that is 6. That's not true. Half of that is 3. Half of 6 is 3. That's why our p-value is 3. Okay, 2 quick examples. Dive into some practice problems. Let me know if you're running into questions. You got this.